Hey there, everyone. I hope you are all doing good. Today, I just received those two modules from Schlappi Engineering. Those two new modules are called Boundary. I just got them. I just opened them and installed them. It's not exactly the first time I used them, as I met Eric this summer at a jam session at a friend's house, and he already had some prototypes. So I've already had my hands on those things. But yeah, I don't really remember most of it. I remember it was nice. So as I just got them, I decided that I will read the manual, trying to make all those things right now out of the box and show them to you. So let's first patch a simple voice. I will use the angle grinder as our VCO, into the 100 grid as our VCF and VCA, so filter and amplifier. So right now I have some sound. So let's get out. We will first use this boundary as our envelope generator. So I'm going to plug the gate to the trigger input as a start. So we can already see it's working. Let's put the gain minimum, the output here. Let's go control the gain. Hooray! It works. Let's send some pitch. Can be very long. Let's use a stackable to control the FM as well on the filter. So we have what I like to call the Schlappi acid. So here I've chosen the trigger input, which is the one where I can just play a note and it will do its thing. As you can see, during the attack phase, it does not reset. It's waiting until the rise has finished to make a new cycle, which is exactly like the Surge Deus G, dual universal slope generator. We could use the slew input, and now the module would stay high when the gate is still high, and fall when the gate is released. So this is more the behavior you want for playing keyboards, and the trigger input will be more useful for sequences. So let's try to see how snappy it can be. That's not bad at all. But we also, here we can apply internal feedback on either the slew or the fall. So if I want to make rise more smooth, by using this, I'm feedbacking this rise into itself, so it becomes more anti-logarithmic. On the opposite, if I want the fall to be more sharp, more snappy, I will make it exponential by switching this little inverting switch over there. So with nothing patched to the control inputs, we can feedback those two together. So now, what do we have? Voltage controlled envelope. modulation oscillator, which means either an LFO or an oscillator. Anyway, because we can put this guy in cycle. So let's use this one in cycle mode to control, let's say, the fall here. Or we could control the rise. It's very interesting to note that, same as the DWSG from the surge, you can divide, if I make this very fast, sending control voltage to the rise input would tie some nodes together, as it will wait until the rise is finished to go back to the beginning. Okay, nice. Now let's see how fast it can go to make some audio rate modulation on one of the feedback parameter from the... Well, let's try to do some FM directly. It can be quite fast. You can probably make it even faster by feedbacking both at maximal. Let's send it to this VCA here, but I just want an attenuator, so we are going to use this. I'm going to send it back to the filter cutoff here. Let's see. Yeah, we can make it very fast. And we can have those vowely sound with the... Okay. What do we have next? Envelope following. So here I have a patch set up with my bass guitar. So the signal is amplified by ears. It's going out into this VCA. I have this one in cycle mode, inverted ear. So basically I'm doing a ring mod patch where the bass signal has its amplitude and phase modulated by this cycle here. And the same signal is going to the rectify input of this one. So this envelope circuit, this Louis circuit, is analyzing the amplitude output of the bass, and it's at the same time controlling the output of this VCA that gets the output of the ring mod here. And it's also going to modulate the fall here. So we have this thing. Let's remove it. If I replug this one. So quite a cool feature here. the usual ring mod patch. If you don't have VCA after it, you will have some bleed from the modulator. So with those two, you can have one doing the ring mod thing and the other one being the clean VCA after the ring mod plus the envelope following. So yeah, quite handy. Let's do some square pushing right now, just to see how it sounds with this. Well, it's quite cool. We have the bouncing ball effects. So for this, I will remove... Oh, actually, I will make this sequence very long. I will use this one as modulation source. And I will send the control out to the bound input. And put this one in cycle as well. And when both... Oh, that's cool. Just fiddling around. But yeah, basically when you send something here, there's a nice video, I don't remember where I'm seeing it, I'm going to search for it, and where it's explained clearly what it does here. That when you set a control to the bound input, it does move, basically rise and fall, and the output amplitude at the same time. So that's why you hear this kind of ping pong thing. Ooh. But this is still being re-triggered via the trigger input every once in a while by the sequence here. But not this one. We could do both, maybe. This is very long. So yeah, you can get quite a lot of interesting rhythm using two, or using another source of modulation. For example, we could use, let's try the bipolar out of the fusion modulator. You can see if you use the unipolar or the bipolar out, things will get different. Okay, what do we have next on the menu? Frequency divider. Okay, so that's one of my favorite things ever. So, for this, we will send an audio output, as it's a square wave, it should work properly. And we're going to send it to the trigger input. And now, I'm going to use the output here and go to the input number 1 of this. So I will remove the original sound here. And I will leave this to drone. Let's open this. So this is our original angle grinder. Now I'm adding on top the output of this boundary. This boundary is being triggered at audio rate by this oscillator. And now if we start to change rise, well, fall, we are creating some sort of phasing or pulse width modulation. But if we start to move rise, we get frequency divisions, like sub-oscillation based on the frequency of this oscillator. I remove the original. So this is how it sounds like. There's plenty of wave shaping available, as we can directly feedback things. And we can have a different sound if we, instead of taking the output here, if we take the end of rise, we'll have a proper square wave with pulse width modulation. This is our original signal, and I'm adding frequency division here. What I like to do with this is to clock a sample and hold here with the same gate, and this triggering the envelope. And this, I will use it to control rise and fall. Get random octave divisions from the original sound. Maybe here we can try with the bound input and see what it does. So here we have random levels as well, which is quite fun. And it's independent actually of what's going on here. So we could add an LFO, for example. Then we have Portamento, which will be sending, let's attach all this, sending the 1 volt per octave output to the slew input, and send this back to our 1 volt per octave. And we can control that slew with, let's say, an envelope, LFO, sorry. So we have the positive and negative slew. And then we have the audio rate wave shaping. That's fun. Sorry for the birds. So here we can send this square wave output. So this was our frequency division, but if we go to the slew, we have some sort of filtering going on. And if we put it on cycle mode, we have some sort of mix between sync sound and low pass filter with sort of resonance. And if we change the behavior, we can make it go way faster. And if we start to modulate things. we are hearing directly the output of this. And we could take the end of cycle instead, or it's end of rise, sorry. Or do a mixture of both in a mixer. Oh boy, I'm clipping to death. So now, time to explore the VCA part of the module. Okay, let's unplug all this, because what's fun here... Let's go back to our basic sounds from before. We have explored basically this part of the module, which corresponds to this area over here, which is all the slewing and envelope LFO modulation part, let's say. And this part here is a 4Q VCA, which means a 4-quadrant multiplier VCA that can be used as a VCA, normal one, or ring modulator. And yeah, it seems we can hit it a bit too hard to soft clip and distort a little bit, which is quite normal for Schlappi thing. So we are going to change a little bit here. We are going to take our main output out of this VCA and use a sine wave from the angle grinder as the input. Okay, let's replay that sequence from before. So here I can just turn up this bias knob, which is just the opening of the VCA. I can change its range. So if I flip it to bipolar, we have no sound here at 0, and then we have positive phase, negative phase. And this is our CV, which of course is normaled from the above envelope generator, which means we can straight away do some amplitude modulation. Some nasty. And so if we invert this, then we have the effect of ring modulator as we go from one type of phase to the other. Which will basically bring back the bass frequency. We can also invert this. Let me check out what it does exactly. Ah yeah, so we can use this for ducking, for example. So there's probably lots more to explore, but as for first patch, let's say that was okay. We'll just keep the sequence going and have a bit of fun with all this. Now let's use this as an output and send the out results from this here. And so we have our envelope controlled by the sequence here. end of rise to this. Now we could before sending this here, sending the envelope into the VCA here and control the output of the VCA. By the way, we have two CV, which is quite handy. One with attenuation, CV1, and one without. So now this LFO controls the output level this filter. We could also probably invert signal actually. I'll dig into that later. Anyway, thanks for watching. This one is let's not end up on a shitty batch. Let's take the clean out. Thanks for watching. See you next time. As always, I will give away some of these sounds on my Patreon page. Check it out if you're interested in some teaching, samples and mastering. Thanks to everyone who's already supporting me over there. That's really making a difference. Bye-bye.